Hello, welcome you all. Myself MP Mishra, Faculty, School of Computer and Information Sciences. In this session, I am with you on a topic, entity relationship diagram. In this session, I will try to discuss what actually the meaning of the designing of database system is concerned. What are the different things that we have to think about when we are going to design a database management system, and what is the meaning of data modeling or modeling of a database management system, database when we are going to design our own database, and in this context what is the role of the entity relationship diagram or how this particular diagram help us in making the design of the database of our own system. So, these are the few points that we will be discussing around, and these will be at the elementary level or at the level where we can just make ourselves comfortable to know actually that what is the database design and how actually whenever we are getting opportunity to learn more about it, we may proceed further and we may know about it. Now, as far as development of the database system or database is concerned, so you can see whole development process in some steps, and that particular is known as the database development life cycle. In that life cycle, you are having some activities which you perform. For example, the very first activity will be there to analyze the system. So, whenever you are going to analyze the system, then you are going to properly understand about system, that how actually the system is performing different operation, how the data in the system is changing, and what are the sources of the data, and what is the different kind of relationship among different data. Those all things you will try to know at the time of analysis of the system. Then you will try to find out the objectives and constraints. At this stage, you will try to formulate the problem, and you will try to see that what are the different constraints under which the system is to be developed, or what are the different rules and criteria which are actually going to be applied for performing the activities of the system. You will be in position to tell at this stage that what kind of platform you are going to use for making this particular database system, or how the different activities which are going to happen will be happening in the system. Now, next step will be there after analysis and finding out the boundary condition or the criteria or rules regulation, the database design. In this activity, you will try to find out the master file, means the file which is having some kind of permanent storage of the data which is not frequently changing, some transaction files, how those transactions files are being used for the performance of manipulation or operation of different kind of data, and on the basis of this you will try to design the database at three level, that is known as the conceptual level or conceptually, physically, and then logically. These three things you have to think about, and that we will be discussing in little detail in the session, that is what is the logical design, what is the conceptual design, and what is the physical design. And obviously, it is very important to work all the things or all the aspects associated with the database design within the defined boundary condition and the scope of the system. And once you have done the design, then obviously the different kind of functionalities which are expected from the database, whether they are met or not, that can be verified with the help of testing process. So, that is called database testing that we have to do, and once the things are done and they are okay, they are working fine. So, next comes that how actually you are having a plan for the maintenance of the different activities of the system, because once a system is developed, still there may be certain queries related to some specific requirement of the user which user is willing to add into system, or maybe some mistakes are there that you need to correct, or it may be that some component or new features are required to be added in the system. So, all these things are always open in any working system, and for that system maintenance is required. So, the conceptual data model defines the highest level of relationship between the management system in which different entities are there and how actually those different entities are related to each other. Relationship among those entities, but at this particular moment or at the conceptual level, attributes of the entities are not considered, and obviously if attributes are not considered, there is no scope of considering the primary key or the key constants at this level. Only the entities and how those entities are related to each other, that is concerned or considered at the time of conceptual level modeling of the system. Then next comes logical modeling. So, this logical modeling describe the data in much detail, and at this stage it is not considered that how they will be physically implemented in the database. It means logical modeling is talking about the detailed description of the data in the system, but it is not having any concern related to how actually that particular database or the database tables will be implemented in the database system. So, at this stage all the entities, their relationship are identified and all the attributes of all the entities are identified, and once the attributes are identified, then what are the primary keys, what are the constants, those are identified. And in the process of the identifying the constants, one important constant that is known as the referential constant, and that is done with the help of one more key concept that is known as foreign key. We are not going to discuss foreign key in this particular session, but here we have to know at least little bit about the foreign key, that a foreign key basically talks about the relationship between two tables, the normalization of the database. Normalization means that how actually we are designing our system so that the redundancy is not there, repetition of the data content is not there, and the complexity is reduced. The tables as per specific requirements are breaken into multiple tables, and despite of breaking the table, information loss is not there. So, if those all activities are done, those activities basically comes under the process of normalization. So, normalization means representing the tables or the relations in most simplest way, as well as taking care of that all the data is available and integrity relationship among the different table is properly maintained, and consistency of data is also maintained. Now, if we try to visualize the difference between the conceptual data model and the logical data model, so we can say that at the logical data model we tried to identify the primary key, but at the level of conceptual it was not there. Logical data model is having all the specified attributes, but at the level of conceptual it was not there. Relationship between the entities with the help of foreign key and the primary key were identified or established at the level of logical data model, but in conceptual data model it was not there. In conceptual model, the relationship among the data or among the entities or among the table is just simply stated, and it is not described that how actually those relationship will be existing with the help of different keys and constants. So, conceptual model is just representing the entities and their basic level of relationship, but at the level of logical data model, that particular has been further expanded. The entities has been associated with their specific attributes. Similarly, the keys like primary key and the foreign key has been identified or defined, and subsequently as per the requirement normalization of the database also has been done. Next comes the physical model. Basically, physical model talk about that how actually you will be writing code to implement that particular. So, physical model is represent how the design is actually going to be built into the database. So, a physical data model can be shown as all the table structure including the column name, column data type, column constraints, primary key, foreign key, relationship among the tables, all those things will be formally defined, obviously maybe by using a specific programming language or maybe in the form of algorithms, so that at the time of implementation it is ready, and just by taking that particular physical model, properly implementation of the database can be done. After discussing all these basic concepts, the 3 modeling and the basic development life cycle of the data model, what we can visualize, what we can conclude, that if we are having proper planning of a database system, then for that it is very essential to properly define the data of that particular system, as well as define the set of operations which are going to be performed on those data. That is why it is very important that what kind of operations or what kind of data you are selecting, so that your all operations can be performed. And at the same time, if you are creating different tables, how those tables are going to be joined to each other, or going to be properly represented with the kind of some relation with each other, those all understanding is very essential. And understanding of all those things, it is not necessary that you are going to do all the things in much more detail, but at the higher level or at the abstract view level. Abstract view level here means that whatever my basic requirement of the system is there, that particular thing I am taking. For example, if suppose we are going to make a simple system for student activities management, then in that case, obviously there will be different student, there will be some facility provider, there will be some classroom, maybe there will be some kind of examination related activity, there will be some kind of teaching related activities, maybe there will be some kind of social activities. So, for all these activities representation, what you will be having is, you will be having different database tables. Now, what will be the attribute of those different table, how actually those different table are going to relate with each other, how many table will be having relation to each other, how many will not be having, how many table will be just working independently. Thinking about all these things comes under the process of data modeling. So, data modeling is very important. Until unless we properly model the data, we will not be in position to design the database system. You can categorize the data model as a collection of conceptual tool for describing data, for describing relationship, and for describing the meaning of the data, and as well as obviously describing the rules and criteria, that is known as the keys and constraints. And obviously the very basic thing, that what are the different data type of the different fields, that also will come under this. So, all these things you have to visualize, not only for the 1 table, 2 table, 3 table, all the tables which you are having in your system are going to have in your system. For all those you have to think about that, then only you will be in position to have a proper design of the database on which you can proceed further, and you can finally implement it for the purpose of operation to solve the specific problem for which you are designing the database. So, in this whole process, there are 2 things that we have to consider as per our discussion so far, that one is the logical modeling we have to properly think about, and the second comes the ER model, that is the entity relationship diagram. It represents the relationship between different entities in the system. Now, before we move further, let me have little discussion about what actually an entity means. So, anything which is having any kind of logical or physical existence in our system and going to participate in the system for the purpose of certain operation, that will be termed as entity. Now, again if we take the example of the student management system, so student is an entity here, because student is having its own logical existence, and that particular logical existence is going to play a role in whole system, that student will register in the system, student will pay fee, student will attend the class, student will submit the assignment, student will appear in exam. So, there are so many activities you can say that that particular entity is going to perform. Similarly, if there is a classroom situation, in that particular classroom students are attending, so classroom also will be an entity and it will be providing different facility. For example, maybe the sitting arrangement, maybe the projector, maybe the different kind of other things that particular classroom will be providing to perform the operation of teaching learning process in this context. Similarly, teacher will be an entity in this system, because teacher also will be contributing in terms of teaching learning processes, and different activities will be assigned to that particular teacher entity. So, all these entities gradually you will try to map into some representation at the ground level to store the data, and that representation ultimately reach to table. So, in a table, a row is representing one individual entity. It means in a particular table, if let us say we are having 10 rows, so we have stored information related to 10 entities in that particular table. And relation, as we have discussed, that relation can be seen at two aspects. One, the relation among the attributes in that particular table or the entity which you are representing, because if one entity is there, that entity will be having its own attribute. If a student is there, a student will be having its own roll number, its own name, it may be the student will be having its date of birth, the age, maybe the address, many more things. Now, here very simple example if we think about that, let us take one example of that, a shopkeeper and you go to shop, let us say frequently or every day to purchase something. So, you are having a kind of relationship with that particular shopkeeper. So, shopkeeper identifies you as well as you also identify the shop. It means whenever you are making a kind of system to understand that particular modeling, in that you will be seeing yourself as an entity, similarly the shopkeeper as an entity, and there will be some kind of relationship between you and the shopkeeper on the basis of certain attributes that will bind you both. The ER model is a kind of conceptual model that is used for representing the real world entities and their relationship. I think now this is clear. So, if you are thinking about ER model, it means you are thinking about a model or a diagram in which you are having entities, then you are having relationship between those entities, and that particular model is representing a kind of relationship between the related entities for a specific system. It is not that any entity is going to participate in this particular diagram making. You will make the diagram of those entities which are actually going to participate in your system or in your solution. That is why identification of entity is also one of the key requirement of proper designing of database system. Now, if we try to visualize the advantage of this particular model or this particular diagram, then we can say that it is representing or providing a clear and readable relationship between the entities of the system to the database designer as well as for the end user. So, if that particular diagram is there, just by seeing that particular diagram you can say that these are the entities, these entities are related with some other entities, and what is the kind of relationship that is also well defined. So, this another advantage of this ER model or ER diagram is that view of an enterprise is composed in the form of the entities and their relationship. So, just by seeing the entities and their relationship, you can visualize the whole system and its working. It maps the relation model, and data can easily be transferred into a relational table. So, in this entity relationship diagram, what actually we are going to use? We are going to use the entity, the relationship, and the attribute. Attribute of what? Attribute of entities. So, for that purpose we use some basic symbols. So, as you can see in diagram, for entity this particular symbol is used. Similarly, for the relationship the symbol is used, and similarly for the attribute the symbol is used. All these symbols are shown you in diagram. Now, which symbol is used for the key attribute that is shown in the diagram here, and if you are having one specific attribute that is having combination of multiple values, then how you will show that, that is also shown in the diagram here. And if there are some attribute which are derived from some other attribute, means they are not totally original, they are on the basis of derivation of some attribute. For example, if employee is there and that particular employee is having dependent, so it is being derived with the help of the employee. So that attribute you can see here, or one attribute you can take here, for example, age. Age is such a attribute that can be derived from other attribute, that is date of birth and the current date. From that you can derive another attribute, that is the age. So, derived attribute is represented by the diagram shown here. Now, one thing is very important here for us to understand, that basically on the basis of the property of the entity, we define the type of entity, and basically entities are defined of two types. One is the strong entity, another is the weak entity. So, strong entities are those entities which are having their own independent existence, but weak entities are those entities which depend on the some strong entity. For example, if again we are taking a normal educational system or university system, in that particular student is an entity and it is having its own attributes, and all the students, as I mentioned, will be sharing the common characteristics. And if you are making a table, so in that particular table you will be having different rows entries, and one row will be representing the information associated with one specific student or one specific entity. So, basically a table content is having information stored about lot of similar entities, and every entity is represented in a single row. Again, if we try to revisit the concept of a strong entity, we can say that it is an entity type whose existence does not depend on some other entity, it is having its own independent existence. One example here you can take, for example, the employee in a department, the employee is having its own independent existence, but again if you take the weak entity, the definition of weak entity says that it is an entity of type whose existence depend on some other entity. So, if employee entity we are taking, and let us say there is a entity that is dependent. Dependent means the people who depend on the employee. So, till the time employee is existing in the system, dependent entity will be existing, and the existence of dependent entity is totally depend on the employee entity. So, on the basis of that you can visualize the strong entity and the weak entity concept. So, symbol used for representing the strong entity and weak entity is shown here in the diagram, and if we try to make an ER diagram, so for that first we have to identify all the entities and the keys or identifier of those entities in the system, and then we have to make the list of the relevant attribute of each entity, then identify the relationship among those entities in the system, and then finally we can draw the ER diagram that can be used as a blueprint of our database design. Now, if we take a very simple example, let us say there is a company entity, in that particular company there is employee entities and there are some projects. So, there is a company, in that company there are some employees are working and there are some project, on those project employees works. It means company is a entity which is having relationship with the employee. What kind of relation? The company, the employee works for company. Similarly, company conduct projects, and what is the relationship between the projects and the employee? Projects are assigned to employees. So, this is the basic relationship between the entities. So, in this system we are having three entities: company, employee and project, and three relationship: works for is a relationship between the employee and the company, and conducts is a relationship between the company and the project, and assigned is a relationship between the employee and project. Similarly, for employee entity, you can have multiple attribute as per the requirement. For example, the employee ID, employee name, employee sex, employee address. So, these will be the basic entities which are required in this system. Suppose we have identified. Similarly, company name, the address, city in which the company is there. So, that particular is shown in the form of the composite address. As the diagram you can see here, this particular ER diagram is shown to you. In this ER diagram, you see one composite attribute has been created. That particular attribute is address, that company address. In that, the address is having further two component, one is the street, another is the city. Similarly, project entity is also having different attributes associated with it. So, on the basis of this, if you are going for a, let us say for this course, you are offered this course online. In this particular environment, you try to identify the different entity, what are the different roles of those entities and how those different entities are performing the operation. Similarly, in normal banking system for a saving account, you perform different operations, you try to see that how different entities you can identify and make relationship between those things, and you can make a ER diagram. So, you practice little bit and you try to do some exercises, you will enjoy it and you will try to learn that how actually the database design concept can be developed, and it will help you to understand the basic designing of the database management system. So, with this I conclude this session here. Thank you very much for your patient viewing the video.